Alright. Hello, this is a video on how to work out combinations. Alright, combinations is basically just the number of ways you can choose k amount of objects from n amount of objects, where nck is equal to n factorial over k factorial times n minus k factorial, where n is equal to or greater than k. But first we have to prove permutations before we go to combinations. Alright. npk is equal to n factorial over n minus k factorial. We're expanding this by n times n minus 1 amount of ways times n minus 2 amount of ways to n minus k plus 1 times. What we do is we times this by 1, which is just, we can say it as n minus k factorial all the way to the 1. This gives us n factorial over n minus k factorial. However, combinations does not take into account the order. So, to get rid of order, we divide it by k factorial. And this gives us n factorial over n minus k factorial over k factorial, which gives us n factorial over n minus k factorial. And that is what we know as the binomial coefficient.
Beautiful.
Alright, a second proof of combinations is the binomial theorem, where it states for every real number above 0 of a and b, we go a plus b, n is equal to the sum from k is equal to 0 to the k equals n, where n c k is equal times n minus k times b to the k. Alright, first let's take this up. How about we say where n is equal to 3? We're going to expand and go a plus b cubed is equal to a plus b times a plus b times a plus b. When we expand this gives us a cubed plus 3a squared b plus 3ab squared plus b cubed. For each term in this equation, we have let a times to the n minus k times b to the k, where this is the 0 term, first term, second term, and third term. We have a times n, where n is 3, and k is 0, where 3 minus 0 is 3, so a cubed, and where b to the k is where k is 0, we get 1. B to the 0 is 1, so therefore a to the 3 times 0, or times 1 equals a to the 3, and we apply that for all of them. Alright, but to get the combination of each term, we have to apply the binomial coefficient, where it states that for every combination from k to n, we times each term by that. And then, finally, we have to add the sum of each. So therefore, a plus b to the n is equal to the sum from k is equal to 0 to n times the binomial coefficient times each term. Alright, and then a special case. Say when a is equal to b is equal to 1. Let's plug that into the formula. 1 plus 1 to the n is equal to the sum from k is equal to 0 to n times n c k times 1 to the something which equals 1 times 1 to the something which equals 1. And then we can simplify that to be 2n is equal to n the sum n c k. Alright, the question we're going to be doing for an example is coming out of 2010 question 7c example. Alright, this question 7ci states a box contains n identical red balls and n identical blue balls. A selection of r balls is made from the box, where 0 is less than or equal to r and less than or equal to n. Explain whether the number of possible combinations is r plus 1. Alright, it's pretty simple. What we're going to do is, we're going to say we choose one ball. How many different ways can we get a different possible color combination? Well, 2 ways. We can get either red or blue. If we choose 2 balls, we can get 3 possible combinations. Red, 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 blue, or blue, blue. If we choose 3 balls, we can get 4 possible combinations. Red, 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 blue, 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 and blue, blue, red. And therefore, what we can say is that for each number we say r is, we're adding 1 possible combination. So 1, 2, 2, 3, 3, 4, and therefore we can say that this is a true statement. Alright, part 2 of the question is asking another box contains n white balls which are labelled consecutively from 1 to n. A selection of n minus r balls is made from the box where 0 is less than or equal to r or less than or equal to n. Explain whether the number of different selections is NCR, where NCR is just the binomial coefficient. Basically what it's asking is n minus r is equal to NCR. How to prove that? First, we're going to say left-hand side is equal to n factorial over n minus r factorial, n minus n minus r factorial. N factorial over n minus r, n factorial, n minus n plus r, expanding it, factorial. Alright, here we can cross out the n's, and this leaves us n factorial over n minus r factorial, which simplifies to NCR, which is the right-hand side. Alright, part 3 of the question, and sorry for the quick change of scenery, part 3 of the question states that the n red balls, the n blue balls, and the n white balls are all placed into one box, and a selection of n balls is made. Using the identity n2 to the n minus 1 is equal to the sum from when k is equal to 1 to n, we go k times the binomial coefficient. Or otherwise, show that the number of different selections is n plus 2 times 2 to the n minus 1. Alright, so using the first two identities, r plus 1 and the binomial coefficient, we can say that choosing a selection of n red balls, blue balls, and white balls is the product of both. So what we're saying is r plus 1 is equal to that times that, right? Here we can expand it to go r times NCR plus NCR. This will equal r times n factorial over r factorial n minus r factorial plus NCR. We cancel out the r and we're left with n factorial over n minus r factorial r minus 1 factorial plus NCR. What this equates to is n times n minus 1 c r minus 1 plus NCR. Right. Then we sum the products to get all the combinations as a number. We go from the sum of r is equal to 1 to r is equal to n minus 1 c r minus 1 plus the sum of r to 0 n c r. And we're saying this one from 1 because we cannot have a negative number or a 0. If we have r is equal to 0, 0 minus 1 is equal to negative 1, and that doesn't work. Alright, here we're going to substitute when r is equal to 1, k is equal to 0, so we have the k, and when r is equal to n, k is equal to n minus 1. What this does, it cleans up this formula. We get n, where we're bringing up n from there, n sum of k is equal to 0 to n minus 1, n minus 1 c k plus the sum of r is equal to 0 to n, where we get NCR. Alright, we know the identities from the binomial theorem, and we've got n to n minus 1 plus 2 to the n. Alright, using the index laws, we know that we can bring down 2 and we get n minus 1. So we have n times 2 to the n minus 1 plus 2 times 2 to the n minus 1. And that equals n plus 2 times 2 to the n minus 1. And that's the question. Alright, summing it all off, I have explained to you combinations, the binomial theorem and the binomial coefficient. And we've gone through question 7C, I to III from the 2010 HSC example.